Hello, everybody. My name is Eike. I'm the founder and CEO of Accensors, and I'm glad and say welcome to our first webinar after a long period. And today I would show you and explain you a little bit of our new sensor portfolio in foil sensor, SMD foil sensors. And 4 o'clock in Middle Europe means a perfect time also that some participations from Asia are here in the room, and also some guys from over the Atlantic are also join us. So thank you for being here. And I know we will do it quick, so maybe a little bit under 1 hour, 45 minutes regarding to the questions, how many we have today. And let's start. So come to the topic of our webinar today. So sensor stickers for printed electronics and PCB technology. Create new solutions for your customers. This is what we want to explain you a little bit, and we want to start, of course, with the problem and the why. And for us as a sensor developing company for the last 8 years, we have defined that there is major need in many parameters. So there are many parameters are not available as standard components. So for example, pH, or also sodium, creatinine, troponin, you cannot buy these sensors as a commodity device, as a commodity element on the market. And the other point is the integration. So some sensors are available, but for applications, and we are on a way, Internet of Things and digitalization with focus use cases in wearables and Internet of Things and some stuff like this. We need flat and flexible and miniaturized sensors. And here we see not a good possibilities on the market. If we go a little bit deeper in this program, that was a Google search from today. So I've searched pH sensor with a lot of results, over 170 million results. But if you go to the shopping and see what are the products that are available and you could buy, this was the first, results we see. And the first is a temperature sensor. So this is not really a pH sensor because it's a temperature sensor. Also with a reflection sensor there, and then another temperature sensor. And the second is a temperature sensor, and but this is not miniaturized, not a flexible, not an easy to integrate, and of course also not a cost attractive sensor. And exactly in this point, we want to create a new possibility. What is the other story we find? Why we have also think about this issue? Here you see from our history one of our stripe sensors. So this is a pH sensor. You could use it as a low cost and ready to use disposable pH sensor, for example, for monitoring fermentation processes. And if you want to measure the pH, you need two sensor elements, a pH sensitive element and a reference electrode. And there are problems in the manufacturing process, because if we do it often in printed electronic processes, if you produce one of these first element, for example, the reference electrode, you get problems in the following production process, because if you want to do the sintering or the UV curing process of the second element, of the pH sensitive element, you could maybe damage the reference electrode. And especially if you talk about a multi-parametric sensor layout with more than 1 or 2 or 3 sensor element, then it will be really worth to find a right production process, following production process, which you don't damage previous processes. You need for the manufacturing of the functionalization, special manufacturing processes. And these special manufacturing processes are often limited in space. And currently you have to take the whole stripe sensor into this process. So that means that the throughput you can do in these processes are not really high. And so this was our idea at the beginning of the last year. And that was not really a idea from our own. We just look around what is possible and what is status quo in other technologies, especially in the PCB technology. So our idea based a lot of PCB technology. So that means we separate the conductive tracks, so the printed electronics or the FPCs or the PCBs, and the electronic components, in our use case, the sensor elements. And our idea is we would like to enable many partners and customers to use our sensors in their systems or their products. So it is from the basis idea, like the same as the PCB technology, where we have PCB board creator, so etching processes for the tracks, and then you go onto the pick and place machine and place the electronic components and have a soldering process after this. But you separate the conductive tracks with the electronic components, and this is what we also want to create, to separate the printed electronics and the sensor elements. How does it look like? So that was one of our first tryouts, our first pilot products. It is the same sensor, the stripe sensor you see 2 slides before. So we decided, okay, let's build the same product again, but in our new concept with SMD foil sensors. So we separated the both electrodes, the pH sensitive electrode and the reference electrode. And for this, we have like 3 separate systems: the periphery tracks, printed electronic board, the sensor, and of course the reference electrode. And with this, we could produce the sensor and the reference electrode in a higher throughput in the production, and that means we optimize the space. And we could bring the production costs down by a lot. And the other point is, if you separate the tracks and the sensors, you create more variant diversity. So that means currently we stick a reference electrode and a pH sensor on this track. But if we change the pH sensor and use a sodium sensor or other sensor, then we have another system. Then we have a sodium system and not a pH system. And so you have more variant diversity in creating systems with different target parameters. And one point that will be upcoming, and it's currently under development, the sustainable effect. So if we have first separate the elements and assembly them together, there is a possibility to de-assembly these elements. And so we have the possibility to put the sensors and also the periphery printed electronic into a recycling process. And that will be, if we're talking about high volumes, one of the major goals for creating a sustainable production cycle. So this is our currently marketing picture with the SMD foil sensors, and I will explain you a little bit more in detail how these SMD foil sensors are built up and how you could use them. And what we want to do is we want to offer a standard available sensor portfolio with new sensor parameters that do not exist on the market, and the integration of the customer system, of your system, should be as easy as it can. And if we create this, we definitely limitate the or shorten it the developing times and reduce market entry cost for our customers. And this is what we want to do. And now I would want to explain a little bit more how the concept looks like. So we built up these SMD foil sensors. You could also call it sensor stickers in an assembling process by us in-house. So we have a basis foil where we create the printed electrode on it. Then the second step is we placed electric conductive tape on this basis foil and on this, but over this free-cutted areal. So this means the right areal at the bottom of the sensor is on one side, on the left side, the E-tape connected to our basis foil electrode, and on the other side it is free on the liner, because we needed to make the connection to the periphery track, to the periphery pad. And the third process is we covered this basis foil with this electrode and of course the E-tape with a cover foil. And the cover foil have a frame. You can see it on the right picture. This frame is an adhesive gluing system, which is available or which is useful for the mechanical fixation of the SMD foil sensor on the periphery surface. So in general, we have 4 elements, 4 points. Let's start with a yellow basis film. Under this yellow basis film, there is a medium adhesive underlayer, so a really light, sticky tape. We need it for our process to do it in the manufacturing, that we don't lose the elements in the manufacturing process. Then we have the E-tape, of course, which goes from the basis foil to the open areal where we want to connect it to the periphery pad. We have the cover foil in green a little bit, which is the isolation of the contacting and the mechanical adhesion fixation of the product surface. And this is a water-resistant additive, of course, and also biocompatible, because one of our target branches are medical and biotechnology. And there is a hole in the middle because our electrodes, if you talk about biosensors or ion-selective electrodes, they need to be in directly contact with the analyte and analyte fluid. And so we have an open hole there. And this is a functionalized electrode. And this is one of our USP, to bring on this electrode surface a special coating which creates the sensitivity of the target parameter. Which parameters are currently available or in developing and will be in the short time available? So we have 3 groups. If we start from the bottom, these are the physical sensors: temperature, moisture, pressure, conductivity, ECG, for example. And to be honest, these are not our major parameters or major sensors, but we need these sensors in our portfolio because the electrochemical sensors or also the biosensors are often temperature dependent. And for this, if we want to create a really accurate measurement system, we also need a temperature sensor. And pressure, of course, is one parameter you often want to have. So we also want to have a pressure sensor in our portfolio. More our focus is, of course, the biochemical sensors. And here we are in a deep developing time. We create a platform, and this platform allowed us to create a lot of different biosensors. For example, lactate, troponin, NT-proBNP, creatinine, hemoglobin. These are really essential and specific parameters in the field of medical, field of blood analysis, interstitial fluid analysis. And if we go on the top, there are the ion selective sensors like pH, sodium, potassium, magnesium. So these are, we do it like 5 or 6 years. We have really deep know-how in this, and create here calibration-free sensors. And this is also one of our points, that we have the possibility to bring the sensors on a level that you don't have to create a one-point calibration. You could take it and use it. Let's go a little bit deeper in the technology. So now we have our SMD foil sensors, but how we could connect them and bring them together with the product and with the periphery surface, with the periphery conductors, with the periphery tracks. So we used here standard available equipment like these label feeders. That is standard equipment in pick and place machines. If you want to stick a label on your PCB, and exact this equipment we could use for our SMD foil sensors. So that means our SMD foil sensors will become on a roll and sitting next to each other on a liner. And you have to peel off our SMD foil sensors from the liner and bring it to an area where a pick and place machine like a vacuum griper could take it and bring it to the next position and place it on your target position. And this is standard. We have only one additional point by the vacuum griper, because for our sticking effect, we need a little bit pressure. And it is really only a little bit, but it's too much that the standard vacuum gripper could do currently. So we need here a special vacuum gripper to create a little bit pressure on our SMD sticker to make sure that the mechanical fixation and the electronical fixation is done really, really good. And this special vacuum gripper are currently under development with the external partner. And I think in the next year we will come up with this retrofittable solution for available pick and place machines. How it looks like, this is one of our demonstration we often present on an exhibition. We have different rolls on the left side with different sensors. The sensors have also different color, this special kind of sensors. So the physical sensors are in a yellow color, the biosensors more in a green color, the electrochemical sensors more in a blue color, and there's the fourth color that is the reference electrode that is often in a red color. And with this label feeder, that is a demonstration of one of these label feeder, we peel off the SMD foil sensor and separate them and give it to an area where the griper could take it and to transfer it to the other side where the periphery foil is located. In this case, our pH stripes sensor or tryout sensor, and place these elements on the surface with a little bit pressure. And with this pressure, we make the adhesion, mechanical adhesion and electrical connection. If we look a little bit deeper in the different sensors, here is for example, one of the ion selective sensors. Every ion selective sensors have the same layout, and also every biosensor has the same dimensions and the same layout. So the sensor currently, and don't be afraid, we are working on more miniaturization, so we will do it much smaller in the size like this, but currently this is our size we are working. We have a 5.6 to 7.6 outer dimension of this sticker, and you see this this cover foil creates a frame, and this frame will stick on the surface, and this area in the middle where the periphery pad will be connected, this E-tape, open E-tape area, is by these ion selective and biosensors have a size of 1.5 to 1.6, and this is for ion selective and biosensors. And if we look at the temperature sensors, because temperature is the most measured parameter in the world, so of course we have also a temperature sensor. The temperature sensor is from the outer dimensions the same, so 5.6 to 7.6, but we need two pads, because we it's a resistant temperature sensor, and we want to measure it with two tracks, and here the periphery pads needs to be a little bit bigger, and so we're talking about the pad of 1.5 to 1.75. That is the diameters for the periphery pads for the temperature sensor. Yeah, how it looks like. Here is one of the example. That is the smart patch periphery layout. It is a sensor or a periphery printed on a TPU film, because we want to stick it on the skin, embedded it in a foam material, and yeah, you see on the bottom of the right picture three numbers, number 1, 2, and 3, and you see, of course, the dimensions of the periphery pads. So from our design rules, we expect that the periphery pads should be a little bit bigger than our E-tape areal is available by the SMD foil sensors, because you have some alignment problems by the pick and place process. So if you have a really accurate pick and place machine, you will not need this little bit bigger pads, but currently our design rules expect that please make it a little bit bigger to make sure that you create a really good connection between your tracks and periphery tracks and our SMD foil sensors. Yeah, and then it's quite easy. You take it and you place it and you stick it, and then you can use it. So you have not a soldering process, you have not a UV curing process. It is only the sticking process, because with the sticking process, you do the mechanical fixation and the electrical connection between your pad and the sensor. And yeah, so that is the easiest way for us to make the integration of this kind of sensor elements possible for you as our customer, and of course for your applications. If you are maybe you have seen also our QR code. So that means the every sensor gets a QR code, because if we want to bring these sensors also in medical or biotechnology products, we need 100% traceability. And that is one point why we decide to bring on every sensor an individual QR code with a ID. And the other point is, for some sensors, if you want to do a really accurate measurement, we need calibration data. but these calibration data you will get from us with this QR code. So this means we have an open online available databases where you could scan the QR code and you see exactly which kind of sensor, what is the manufacturing date of these sensors, in which batch, and some stuff like this, of course, traceability. And if it is required for these sensors, you will also have the calibration data, maybe 1-point calibration, maybe 2-point calibration. And for the usage in a customer product, that means you could collect several sensors together, bring it in a new QR code, and say to the end user, hey, before you use this product, for example, this smart patch, please scan this QR code, and then you get the calibration of every sensor you have placed in this whole system. So you can have really a ready-to-use system without one-time calibration or pre-calibration, because we will do on-site calibration from our point of the manufacturing. Why we have developed this product portfolio? Because so that our customers have access to readily available, easy to integrate, economically attractive, flat, flexible, and miniaturized sensors. And we want that our customers to be able to design and realize multi-parametric sensor system independently and freely. So we will go from the history one step back in our value chain, and we will not do the whole printed electronic system, because we will focus on these sensor elements, on these SMD foil sensor elements, but we want to be an enabler for you, that you can use our sensors for your product or for your products for your customers. So what is our major, or where are our major focus sectors? We are looking, of course, in medical and biotechnology, and environmental monitoring, agriculture, as well as Industry 4.0. We have one point that is often time to discuss, because our sensors, and I see also one of these questions in our Q&A session, there are in a limited use of time, or time of use. That means if we are talking about biosensors or these ion selective sensors, the sensors needs to be in directly contact with the measurement analyte, like drinking water, blood, urine, or something. And these sensors will be get an let's call it outbleeding effect after a while, and this while is 3 to 5 to 7 days. Depends a little bit on the sensor, but our sensors, biosensors and ion selective sensors, are with a major focus use time of up to 4 weeks. So we will not create biosensors and ion selective sensors for special use time over 4 weeks, because that is not our focus area. We want to bring consumable products like the wound dressing, like the drain catheter, like the agriculture monitoring system for the first weeks on a new level. And for this, we developed this kind of sensor and sensor portfolio. The physical sensors, like the temperature sensor, the pressure sensor, here we are not limited in the use time. So for the temperature sensor, we are also in some automotive projects. And if we talk automotive, the lifetime is 25 years, a whole auto life. And because these sensors are not in directly contact with any liquid, so you can use it also longer time. But so that just to make it sure, the ion selective sensor and the biosensors are not for a longer use time than 4 weeks developed. Yeah, the sensor integration is the key to making products smarter and more effective and efficient. And so we could support us in our everyday lives. That is what we want to do, and we will be one of the sensor supplier for several customers, for several products. And yeah, we are happy if maybe we could work together. So this is a new product, and we are currently on a rollout period phase. And so we need yeah, pilot tester, pilot customer. And yeah, we will be happy if you are interested in testing our sensors, because yeah, we want to also understand where we maybe have problems or where we have really good feedback for our sensors. And if you are interested in want to be one of these pilot customer, please let us know. Then we could yeah, get and create a small project where you can get sensors and we get feedback. And that is currently the next period for us to entering the market. Yeah, let me bring a little bit the outlook of the upcoming events, because we're starting a small webinar series. The next webinar series is more on an economic point of view. So sensorification, the opportunities and risk of product development departments. That is something from our yeah, from our feedback and knowledge, working together with customers. Because if it is possible with our sensors to make a stupid product intelligent, that is nice, and that is everybody wants this. But there is yeah, a little bit more work than only the technical work. Because if you have at first a stupid catheter and now you have an intelligent catheter and you get data from this catheter, what does it mean for you as a company? Because currently you are a stupid catheter supplier, and now you are an intelligent catheter supplier, and you have data, and maybe you don't know what you have to do or what you could do with these data. And this will be the topic of the second webinar on Wednesday, 22 of September. And then we go a little bit back into deep tech. And let's go a little bit deeper into the biosensor stickers, because there is some yeah, some other aspects that will be go too far into the deep technology today. But on Wednesday, 11 October, we will talk about lactate, troponin, and also creatinine. Yeah. Thank you very much. It was a short presentation to bring a first impact of our new technology. And now it's time for questions. And I see there are a lot of questions, but please feel free to write your questions also in the Q&A session. There was some first questions from Jack. Are these all sensors reusable? No, they are not reusable. You can reuse these physical sensors, but you will not reuse the electrochemical sensors and the biosensors. Maybe you could do this if you do this in the expected lifetime, but be careful, because you have a contamination, because you have a directly contact with your first analyte, and if you put it into a second analyte, then you have a contamination. So normally the biosensors and ion selective sensors are not reusable. Interested presentation from Philip. 2 questions. Are the pH sensors calibration free? Yes, they are calibration free in a limited accuracy. If you want to have a higher accuracy, you could use the QR code with from our side given calibration data, and then you can do a better measurement with a higher accuracy. If I buy a pH sensor, I also need to buy a reference sensor, since the reference electrode isn't included into the pH sensor. Yes, that is right. We decide to split the ion selective electrode up to the reference electrode, because if you think about a multiparametric sensor layout, pH, sodium, potassium, magnesium, for example, you have only used one reference electrode. That means for measurement ion value, you need 2 electrodes. But if you want to measure 4 or 5 different ions, you only need 1 reference electrode. And that means we decide to split up the reference electrode from the other sensitive ion selective electrodes, that we have more freeness in designing your sensor system. So you could use the reference electrode for the reference for several ion selective sensors. Which accuracy the temperature measurement have? We will use here that is not a printed temperature sensor, because the accuracy of printed temperature sensors are good, but only in a really limited temperature range. And we want to create a temperature sensor in a wider temperature range, so up from minimum -20, maybe a little bit less, up to 80, 90 degrees, but with a really good accuracy. And we used an element with an accuracy of 0.1 Kelvin, but there could be a little bit raise up of the tolerance, because we embedded this element in our foil sensor concept. But we definitely will raise up to 0.2. So this is our target, and currently it looks really good. And so hopefully we have 0.1 Kelvin. Currently we have 0.2 Kelvin. So currently I don't see more questions. Please feel free to also contact us after this this meeting or in the next days. And if you are interested to be one of our pilot customer, please let us know. We want to explore and validate our technology, our new product portfolio together with you. And please, if you are interested, get in contact with us. Oh, there's one question. I understood the intention. This is standardization, but can we customize the sticker layout if required? Yes, of course. The idea was we developed in the past a lot of customized sensors, and that means often starting from the scratch, and the developing time and the developing effort is really high for this, and especially when the customer maybe not really know what how should look like the target sensor. And so we want to have a portfolio that makes it possible to in the first period to use the standard sensor and to test the standard sensor and to bring the product on a material level. And if you see, okay, the dimensions, the geometric dimensions, or maybe also the parameters, lifetime, accuracy, setup time, are not really fit my needs, then we could start in a customized development. But to be honest, to present us as a company only to say, hey, we are the guys with you could develop the own sensor, that is a hard business. So we decide to bring at first the standard portfolio, but there's one rule: if you have a standard, there was also one time you have no standard, and that we develop together. One new question from Thomas: what is the cost difference between the fault sensor and the comparable wire sensor, e.g. for temperature measurement? Yeah, good question. So I guess we are if we look on the temperature sensor, you are right. We are in a competitor situation with a wired temperature sensor. But if you want to measure more than only temperature, biosensor parameters, ion selective parameters, you maybe will use only one technology, because it is really easy. If you placed 4 sensor elements, you could place the 5th sensor element, the temperature sensor element, to also get the temperature value, as you have 4 SMD fault sensor elements, and then you find a way to integrate also the wire sensor. From the cost, I guess we are nearly on the same level, but if you only want to measure temperature, I guess a wired sensor is a really good way and a really good opportunity. If you want to create a multi-parametric sensor layout, you could decide it, but from the assembling process, it will be easier if you use the SMD temperature sensor, because you have not a broken assembly process. Okay, then thank you again. It was a pleasure for me. Also, after a long time, have my first webinar, and you will get an email after this meeting with also a recording of this webinar, and there will be also a small feedback form. And we are really happy if you could give us a feedback of this webinar, if your suggestions are fulfilled or not, because only if we get feedback, we could also optimize us and our work. So yeah, thank you very much, and have a good night, a good evening, and a good morning to all the participants. Thank you very much. Bye bye.